Angle Relationships, Lesson 2. In Lesson 2, we're going to cover several of the angle pairs that are created when two parallel lines are cut by a transversal. We're also going to look at the relationships between those pairs as far as complex algebraic expressions. Lesson 1 review, we proved that the measure of angles across from each other when two lines cross are equal. We also looked at a pair along a straight line that summed to 180 degrees. We proved that. And we solved some algebraic expressions, both simple and a little bit complex for both of those pairs of angles. Lastly, we talked about that there are a number of pairs that have to be remembered, and we're going to look at those in this lesson. And each of those pairs, either they're equal to each other or they sum to 180 degrees. We're going to have some definitions you can see on the right side in the white boxes, the parallel lines. And also some common ways that in geometry and math, how things are expressed. You can see here, this is an expression, line AB, expressed here, simply here, is parallel, this parallel sign, to line CD. And you can see that they're capital letters that indicate it. Transversal cuts lines, parallel lines. And the angle is indicated by the red lowercase letter. We're also showing a common expression that's used in geometry where angle A is equal to angle B. It's an expression here. Turns out these angles across from each other are vertical angles. They are always equal. And if we look at the red pair, there are two pairs of those, and all of those angles are equal to each other. So if we know what angle B is, we know automatically what angle G, H, etc. are. Let's say that angle B is expression 13x plus 2 degrees, and that angle G is 80 degrees. We already know that they're equal to each other, so we can express them via an equation, and we can solve that equation. Here's the equation, and a two-step algebraic process. We subtract 2 degrees from both sides. Now there's a common error that students often make, and in this case, instead of subtracting 2 degrees from the plus 2, sometimes students subtract it from where the x is, and that's inappropriate. You get uncomfortable responses and make an error. You can see that these usually happen when there's subtraction or addition being done on both sides of the equation. They tend not to occur as often with multiplication, divisions, roots and squares, and those kinds of operations. The proper response is, or answer to this mid-step is 13x equals 78 degrees. Divide both sides by 13, and you get the proper answer is x equals 6 degrees. There are other vertical lines as indicated by the black letters, and similar to the red ones, all of these angles are equal to each other. And let's say that we have angle C is equal to 86 degrees, as indicated here. And let's take another angle, let's say a red angle, and let's say that is equal to 13x plus 2 degrees. They're not equal to each other. We know that their sum equals 180 degrees, which gets us into a definition of the two other angle pairs that we're going to talk about in this lesson: supplementary angles and linear pair. what's great about this, if we look at a linear pair, it's a special supplementary angle we covered in lesson 1, is that if it's along a straight line, those two angles, when they're cut by another line, the sum equal 180 degrees. And so you can see the expression that we have in the yellow is this is the equation for that expression and the relationship between those degrees. So now let's test for some understanding. We're going to take 3 parallel lines. We're going to cut it with 2 transversals. What is the angle relationship between the angles in these expressions? You'll also notice that I've introduced noise, meaning information that's not needed to solve the problem. And often this happens in math to really test if you really understand the concept. In this case, the parallel line CD is not needed. It's extraneous, it's noise. We also have a transversal that is noise, meaning it's added information that's not needed. Thirdly, we've added in the question itself something that we haven't covered yet. It's one of the angles that we'll cover in lesson 3. It may seem like noise now, but in the future it will not be. So that's why the question marks. Now let's get rid of the noise in the graphic that we see. Now let's look at the relationship. We can see it's supplementary angles is the relationship. And this is the equation that expresses it. Let's test for understanding. 3 parallel lines cut by 2 transversals. A little bit different here. These things here are called, I call them gotchas, meaning complexity has been added to throw you a loop. Typically, when we're looking at expressions in relationships, we may look at this as being, let's say, x, and this being, let's say, equals, I don't know, let's say 80 degrees. And we know that they're supplementary, so x plus 80 equals 180, and so that's simple to solve. But usually it doesn't stay simple, it gets complex. And so you can see that a complex gotcha has occurred here. We're not going to get rid of the gotchas of complexity, but we can get rid of the noise. And now we can solve this equation. Let's test for understanding. Let's solve it. What is the value of x in this expression? And notice in the expression that I've encapsulated both of the expressions in left and right parentheses. And one of the reasons why is that sometimes this is a minus, and that changes what goes on here and what happens when you combine and simplify. Okay, so the first things we're doing are we're going to simplify and combine. And you can see that we're taking the x's and we're combining them, putting them along together to add up to 23, and we're taking the non-x's or the degrees, adding them so they sum to 19. Now we can solve this like a simple 2-step algebraic equation. We subtract 19 from both sides, and note that the 19 is from the degrees, not from the 23. We bring the 23 down, this equals 0, and the difference here is 161 degrees. Also note that one of the things that I like to use is make sure that your equal signs are all under each other. That kind of helps make it clean. We subtract. Now we're going to divide both sides by 23, and the answer is x equals 7 degrees. And if we look at our question, we can see the answer is none of the above since it's not expressed there. Congratulations, you've completed lesson 2 of angle relationships. In lesson 3, we're going to cover the remaining pairs of angles that are created when 2 parallel lines are crossed by a transversal. And we're going to look at more complex algebraic expression and equations for these pairs. And we're going to have quizzes on lesson 1, 2, and 3 material with noise and gotchas.